So, oops, can't show you the first. Done that twice now. Okay, so we're going to go find out if these things are a palindrome. So essentially what a palindrome is it's the same forward as it is backwards. So for instance, like a word like race car is the same forward and backwards. So if I say race car, if I spell it forwards, it's race car. If I spell it backwards, it's race car. That's palindrome. In a string form, we're going to deal with them in integer form. So we're going to return a Boolean value if it's a palindrome, and then not if it's false. So we'll have to deal with negatives, and we'll have to deal with non-palindrome numbers if it's 0 to 1. So we have a 32-bit integer constraint, and what we're going to do is we're going to try to do it without converting the integer into a string. So we're just going to do it in an integer mode, which is a little bit more difficult, but this is something I figured out later with the help of a friend. So what we'll do is we'll use some modulus functionality to extract some digits from the end of the number that's going to be input, and then we'll kind of use a pointer approach where we'll compare each end of the pound, like each end of the I guess you could call it array, but it's going to be, we're going to add these digits to the array, and then we'll kind of point towards the middle and then see if it's palindrome. So we're going to first put number is equal to x, just so we can read it a little bit better, and then say if the num is less than 0, we're already just going to return false, just to have a sanity check for this. Not that we'll need it, but you never know with test cases. So we're going to go ahead and put a digits piece here as well. So we can instantiate an array we will add to based off of what the number is going to do. So we're going to go through a while loop for each number in the well, you'll see how we do it. So we're going to go through a while loop while the number is greater than 0, and then we'll do some modulus functionality to manipulate the number, and eventually we'll have 0 at the end. So while the number is greater than 0, we're going to, what we'll do is we'll use the JavaScript unshift that will extract the last digit of the array and put it on the front of the digits array. So we're going to do digits dot unshift the number modulus 10, which essentially just says the number divided by 10, so the input divided by 10, and it will extract the remainder of that. So if it was like 18 divided by 10, it will extract 8. So what it will do is it will add 8 to that digits. So that last digit, I guess you could say, now becomes the first element of the digit array. Oops. And then what we'll do, we'll make the number equal to math.floor of the number divided by 10, which just essentially will bump out that second or that last digit of the array. So if it was 120 divided by 10, that's going to be right around 12. It's going to be 12.1, but with math.floor it'll just be 12. So then the number, now that it's the next digit, it will become 12. It's greater than 0, and then it will do the same thing until you get to 0. So now that we've got a digits array built up, we're going to instantiate the length of the digits array. using the length function to extract that length. And then we're going to go do a for loop where we touch both sides to see if we can, it's a palindrome. So we're going to say let I equal 0 for a counter, as I is less than the length divided by 2. So we're just going to have to go through half of it, because if one half is the same, the other half is also the same for at least a palindrome. And then we'll just do I++ to increment the counter. And then we'll come and do a Boolean check. So if the digits sub counter is not equal to the other side of the digits sub length of the digits minus the counter, which is 1, minus the other counter, which is 1, which just essentially is saying since we're starting at 0, it's going to just start at the end of the array. If those are not the same, then we'll just go ahead and return false. And then if it goes through each one of those pieces of the array and it does not satisfy this condition, then what we'll do is just return true, because then we know that is a palindrome. So essentially right here, we'll reverse the order and then we'll check if it's a palindrome. So there we go. Technically you could do just one of these, but with reversing it, it gives you a little bit more of a sanity check for that. So let's see if it runs. So we can see that it's a palindrome, not a palindrome, not a palindrome. Submit it. Looks like we did fairly decent with this, since there's two loops that technically will go through each one of the pieces of the array. It'll be right around O of n. Might be a little bit less because you're only going through half of the array here. So technically it's right around O of n once you take out all the constants. So there is problem number 9.